Hi. So, after the orientation last week, this is the first lecture of the TA class. So, I just believe in that there will be no much thing for today because we are just going to deal with fundamental things. So, I think I have to teach you some knowledge of the R programming grammar as well as the chapter 1 content today. So what you have to prepare is the R file in this R practice file folder, whose name is chapter 2, and also the data CSV file. But actually, the CSV file in this folder is same to this data CSV file. So it doesn't matter whether you prepare for um, either one in the main section or the R practice file folder. So we it means that we have two files. One is R file, and the other one is CSV file. So I just heard that you learn about the. Actually, this is very the fundamental thing in statistics. So because this is the introduction to statistics course and the first class of that course, so it must be very fundamental thing. Yeah. So I heard that you learned about the descriptive statistics, which is just visualizing the result or the some shape. And yeah, so we just observe a sample by visualizing or getting some result from the our sample or our data. So for the descriptive statistics thing, we have we can actually visualize the sample with the tabular and graphical presentations because it makes us understand the sample easily and more intuitively. So we have six kinds of visualizing things. So what they're going to do today is just follow the steps with this plot or table or chart and histogram. So I will, and as I yeah, in addition to that, I will assume that you already know what each of plot or table is and what it means actually from the sample, and we will use this kind of data as we already downloaded. So let's open the R file. Yeah, and some students ask me about the how they can open the R file. I think they have not yet installed the R Studio yet. So I want you to make sure that you already download or install the R programming and R Studio, both of the programs already to open the R file. So yeah, that's it. So actually this what we already did last week. And as we already did with, for opening the CSV file, we have to set the working directory in our own path in our computer, laptop, and use the read the CSV function to open the CSV file. So um, let's do this first again. Because made I installed the R Studio or R programming in the local disk C drive and program files folder and R folder here. So this has to be, or this may be my working directory for now. So I have to put my own CSV data in my working directory. So whose name is chapter 1 dash, yeah, this kind of name. And because we put our data in our working directory, we also have to say that declare that our working directory is here, C drive and program files folder and R folder, which means that we are going to work in this working directory in this path. So with Ctrl Enter, you can run the code. So uh, in the you can see that in this panel, the code is run, and we can see that the result here. So read the CSV function. With this function, we can open the CSV file and we can store the data table in our own variable. So yeah, let's say that we have done this one, and I will explain a moment later. So this panel says that we have a data table, data frame, whose observation is about 6,000 and with 6 columns. So if we run this data, dat, so this is just code because we store our data table in our own variable. So this is just call to call. This is calling our own variable now. So with Ctrl Enter, you can see that the result of the data table, which means that we successfully opened our CSV file, and there are some kinds of checking the sample function. So with view function with the uppercase in this first letter and our own variable dat, you can open the another uh, slot for checking the data table more easily. Yeah, this is just a R function, and we can also check the dimension of our own variable, so our own data. So you can see that the data dat, our own variable, has about 6,000 rows and 6 columns, which are the dimensions of our own data table. And there is also head and tail function, which shows the first 6 rows or the last 6 rows of our dat data. So we can check the 6 rows from the top or the 6 rows from the bottom, the last 6 rows. So as you can already, realize that we can use some kinds of functions in our programming, and I think this is the time I have to teach some knowledge in our programming, or even as well as the computer programming itself, because what I'm going to explain is actually based on a lot of programming language, because it is very common to in computer world. So uh, actually, oops, yeah, let's do it. So for programming language, we can actually calculate some formula. Let's say that we want to get the result of the 1+1, and you can easily get a result from the programming. So it shows that we can use the R programming or any kind of programming for our own simple calculation. So which means that we can use this as a calculation very easily. And there is also some function. Okay, so before that, I think I also have to explain about the variable. So let's say that we have the number 3, and this is actually just number 3. So this is a constant thing which cannot uh, vary. So, and how about, um, so let's say that we want to make our own variable. So it has, it doesn't have to the fixed name. So we can call it A or B, or we can also say it as a Neulpum. And we want to store, because this is just a variable without any value, so we can store our own value into our variable. So let's say that we want to make our own variable whose name is A for simplification. So this is actually not same as the mathematical equation, because um, in computer language, it means that we are going to store the right side of the value from the right side into the left, into the variable in the left side. So you always have to understand each code from the right side to the left side. So it says that we want to make our own variable whose name is A and whose value is 3. So after running the code, it says that we have a variable A whose value is 3, and you can also see the result in the environment panel. So which has a value A has a, yeah, which has 3 value, which has value as 3. So it means that A is 3 for now. So um, how about running this kind of code, 4 plus A? It makes sense because A is already called as 3. We can add to each other, to the some number, any other number. So this is same as 4 plus 3, which is a 7. So we can see the result as a 7. So yeah, this is actually the basic basic R programming. And how about, yeah, because A is just a nothing but just a variable, so we can change each value. We can change value um, anytime. So uh, we can run also this code. So and you can check in this environmental panel that A has the value as 2 from now on. So if you check the A, it says that A is 2 now. Yeah. So actually this is variable. So yeah, this is an equal sign, but this is same as the arrow sign here. It is more intuitive because we are going to start from the right side and end with the left side. So this is the reason why this is code is composed of this arrow sign. So actually you can now understand that we are going to store the result from this function into our own DAT variable. So this DAT name, this name DAT is very arbitrary thing, and it doesn't matter for any name. So yeah, that's it. I think you can from now on you can understand what is going on. And yeah, this is there's one more thing, and this is a comment per comment. So this sharp sign, when we add the sharp sign in front of our own code, it makes the code as comment. So this is just per memo, so that compiler cannot recognize what it is. So if you don't want uh, that compiler recognize this code, you can make it as a comment with a sharp sign, by adding the sharp sign here. So if even though you run this code, it doesn't say, it doesn't run. So yeah, this is how we make it as a comment line. And there is one more thing. So actually, as I already know in mathematics, there is also function things in our programming. So actually, for this, for now, set WD is also function, and read a CSV function, and view function, dim function, head and tail function. So actually, there are already tons of function that our programming already have for us. So what you have to do is just utilize the each function for our own for our own goals. So as I already know, every function has to have its own input. So because the header or any other function for now needs the data table, we put our DT variable in this location for the argument for the function. So that so this is the reason why dim function gives us the dimension of the DT variable for us, which is a result like this one. So I think these two kinds of knowledge, like which are a function and a variable, is the most important thing in any other in any computer programming. And you will see a lot of and tons of function or variable in the R code from now on. So if you are not familiar with this concept, I think you should refer to some material in Google, because there are a lot of explanation in Google. So I recommend you Google or ask to me or your friends for better understanding. And I think this is the time uh, we can go ahead to the main point, to the main concept. So, and actually, because this is not our programming course, this is the Introduction to Statistics course. So, I think there will be not much difficult thing for this course. I mean, uh, in the aspect of the R programming. So I think I will not explain actually every detail for the R code or every detail of the result or any logic or any algorithm in our R file, uh, because this is just a statistics course, not a R programming course. So, and actually the content in our practice file is somewhat easy thing. So I think you can follow my practice very well. And yeah, okay, let's do it. So Yeah, what you're going to do today is just following the six plots or visualizing things today. So the first is with a frequency table. Actually, frequency table is nothing but the table which shows us the frequency of each data. So because it is kind of the original data was already kind of continuous data, which has a lot of numbers, and we want to store the frequency into our own standard, which is yeah. So we want to check the how many datas in each bin, and yeah, with the frequency column, and we can also check the relative frequency from this frequency table, and you already know how to what it is actually. So what you are going to do is just doing the same thing, and yeah, let's say that we want to get the frequency table of the weight column, which is HE-WT. So I just run the view function now, and if you check the columns, we can see that this is the column per weight per each patient. So we want to get the data from the the last column, whose name is HE underbar WT, in our own DAT table. So this is the code for getting that column. So this dollar sign is for getting the certain column. So because we have a DAT data table and we want to get this column, we use the dollar sign. And we want to store the data from the column in our own variable whose name is WT. So you can check that the WT has these datas. And for just a simple check, we can also get the maximum or minimum value with these two kind of function whose name is max and min. And you can say that, yeah. You can check the maximum value or minimum value from our own WT column very easily. And yeah, and this code is for getting the frequency and relative frequency table. So let's do it first. Let's run all the code now. So after I run this code, or you run this code, you can see this frequency table, which is a bin in the first column and the frequency in the second column and the relative frequency in the last column. So actually this code is for getting the frequency table. And let's check it. Yeah, step by step. And I think because actually this is not that important grammar, but there are a lot of there is some complicated function here, which is a sequence function, whose name is seq, and cut function, and transform function. And yeah, so there is some functions here, but I think I'm okay with explaining every detail of the function, but I think because this is not that important in this course, so I will skip some explanation for each function. And you can always Google how to use each function. So, and I think, yeah, it's not that important in our programming or maybe in our examination. So, yeah. So, yeah. Let's do it. So I will just explain each function briefly. So sequence function is a mm, yeah, we can check the sequence function. So sequence function has three arguments. So this is the start value and end value, and this third argument is step. So we are going to get all the values from the 30 to 150 by 10 steps. So you can see that beans has uh, these values now, which will be our beans in the first column. And so yeah, with the cut function, we can actually uh, classify each value into our own beans. So with our data and beans that we already stored, we already got here, you can use the cut function to classify each value into our own bin. So this is a we call it as a WT underbar value as a variable. And with the table function, we can make it in the we can get the frequency actually based on our own bin and data. So and with the transform function, we can make the table in we can make the data into the table form for our more vivid visualization. And we can store the table with the same chart this one into our own variable whose name is freq underbar table variable. So and we also get the this value here. So yeah, and for getting the relative frequency, actually we have to divide our own each frequency into the by the total number, total value. So which is the sum. So actually this is the very common function, very famous function. So we can get all the summation value of our own data, and we are going to store the value in our own variable, which is the 6,000 about. So we can, so actually we already have our own frequency table here, and we want to add the relative frequency column here in the third column. So we can add the uh, the column in our own table whose name is relative frequency. Yeah. So for getting the relative frequency, we have to divide the values by the total number. We already got each variable here and here. So after dividing the values, we can store the values here in our column. So you can see that we have also third column, which is a relative frequency now. So this is just a relative frequency table. Yeah, frequency table. So this is just how to make the frequency table with the code. So even though we have different data or different data table, we can always make frequency or relative frequency table with this code. So you can refer to this content. And the second thing is the pie chart, and bar chart. So this is nothing but just visualizing how our data is distributed. So from now on, actually, I will not explain every detail. So you can just understand what it is, and I think it is enough that you understand what is this bird and what you are going on, what you are doing now, very briefly, because this is just visualizing things. And actually, when you have to visualize some data, you can just change the argument into your own data after you store the data into your own variable. So what you have to do is just change each value or uh, each argument. Yeah, because we are always using the same function for same result. So we can use bar plot function for getting the bar chart. So after yeah running the code in above, you can see the result from the bar chart bar plot here. So you can amplify the image with this zoom button. So you can see that you can see the distribution of the smoking status. So with the bar plot function. And bar plot function actually need our own data, and maybe this is the x-axis column, and this is for the yeah bird color, and this is the title and x-axis name, y-axis name. And for the table smoking data, we can get the here. So with the table function, we can get the data of smoking status, and this round function is nothing but make our data. So this is just for rounding up function. So and you can also do same thing with the pi function for getting the pie chart. And after running the code, you can see the this pie chart. And there is also histogram for the you can get the same result from the previous one. And there is also histogram, so we can also check the distribution with the histogram function whose name is hist. So it also needs the data and our own breaks, which is actually maybe the bins. So the the amount of the data which has to be put for each bin. So and this is for title and x-axis name, y-axis name, and color, etc. And with the after getting the WT with the hist function, you can get the histogram easily. So actually, our programming does everything. What we are doing is just clicking or repeating the Control Enter thing for running the code. And the second line is actually very similar to the previous code, but the only difference is the last option, which is a frequency as a force, which means that okay, so you can check that the y left is about frequency, just a frequency, but with the frequency as the force option, you can see that the y value is decreased. So actually this is a probability because we turned off the frequency option now, which means that we are going to get the relative frequency or the probability of our own data. And this is just a line function. So we can after we get the density of the WT with the density function, we can draw a line in our histogram above. So this is just a visualizing thing. And there is also box plot here. So you already know what box plot is and each content of box plot. And what you're going to do is just drawing the box plot now. And so with the summary function, you can get each important value or important information of the data which is a minimum or burst contour, and or yeah, median or mean or maximum like that. So we can check this as a numerical number, but we can also check the some kinds of contour value with the box plot. So with the box plot function, you can get the result of the box plot. So it has a minimum or maximum or some outliers or some median or yeah contours. So and this is just for customizing the box plot function. uh, we can give the box plot our own color, but as you can see, it is not important. But if it makes you happy, you can do that also. And with this horizontal option, you can also rotate the graph, but this is not important actually. The important thing is that uh, we can just draw the box plot anyway. So the fixed thing is the time series plot. So yeah, if we have our own time series data, we can draw our time series plot. So the x-axis is the date and y-axis is the value amount of rainfall. So for preparing the data, the time series data, we can make our data frame with the data.frame function. So this is the time column and y column. So and after making the data frame with this function, we store the result into this rain det function. So rain det variable. So you can see that this rain det variable has this kind of data frame now from now on with the time and y column, which means that we can use the plot function for plotting the data here. So actually there are 5 kinds of plot, but we use the same because we use the same data. You can see that this is just for customizing. Uh, so there actually I think the last one is the most sophisticated thing because it seems good actually. So the last one, the last code from among the 5 code. So you can check the result of the plot function. Yeah, actually there's nothing I can explain more. This is just for yeah time series plot. Good. And the last one is the scalar plot. So it needs two kind of data, x and y, and we can get some information of the relationship between two data with this scalar plot. So yeah, some kinds of relationship as you already learned in the Professor Park's class. So what you're going to do is actually just getting the relationship. I mean, getting the scalar plot. This is the same function, which is plot function, and we have to use the two kind of data for x and y. And this is just for option for customizing. So after you run this code, you can get the relationship for by getting the scalar plot between two variable, which is a weight and maybe this is a blood pressure. So you can see that actually there's no strong relationship between two variable, but we can somewhat say that actually there is somewhat positive relationship. I'm not sure, but for checking the relationship more better, we can also draw the linear line. So yeah, this line just shows the linear relationship between two variable, and actually the slope is almost zero. So actually, we cannot say that there is so much strong relationship between two variable like that. So this is what scalar plot is, and I think you can ignore the ln what is ln function because this is somewhat difficult thing for the introduction to statistics. So uh, I recommend that you ignore. But if you want more explanation, you can Google. And although there's no content in the our own class material, there is more contingency table or outlier thing, and you can just check the result mm, from this code. But this is not important. I just give you this code uh, per your future. I mean, if you there sometimes there comes some timing that you have to use the contingency table maybe, but I'm not sure. But yeah, this is just for yeah. This is not the important. So if you are interested in this contingency table or outlier, you can check the code or get a result. So yeah, for the outlier, we can get the outlier from our data, and we can also draw the line for getting the uh, result of the outlier on our histogram. So it means that the right side of this outlier line can be classified as an outlier like that. So what I did today is just showing or introducing some function for visualizing or plotting our own data. And I think the important thing is that you understand what variable is or what function is in our programming. And I think you don't have to memorize all the functions for your examination or for your assignment. The important thing is that you um, understand how to use the functions for our goal, for visualizing. And in addition, this is nothing but visualizing our data. Actually, we cannot say that this is truly genuine statistics. This is also statistics, but we didn't deal with some numbers yet. So I think you don't have to be pressured for now. And please just uh, yeah, do not worry about much thing. And this is the end of the class, and have a good day. Thank you.